How were scores awarded in May of 2020? In normal times, IB produces grade boundaries that follow the formula that's in our guides to explain how they award scores. Usually, they take our rubric marks, multiply them by a scaling factor that creates the percentages that added up equals an out of 100 score that is converted to a 1 through 7. However, in May of 2020, we did not give exams. So, how did IB award scores? First, student coursework, the internal assessment. We usually submit a sampling for moderation. In May of 2020, we submitted all of our internal assessments, and all of them were rescored. Using school predicted grades. In other words, what did the teacher believe the student would earn? And then the third factor, which is explained in a document called Awarding May 2020 Results, further information published in July of 2020, says that IB used a formula called school context. For each subject in each school, a unique factor was applied based on historical prediction data, and the same factor was applied to every student in that school for that subject and that level. Let's explain. These are the grade boundaries for May of 2020. It would take your internal assessment number, the rubric score, in this case my example is history, the rubric is out of 25, multiply it by 4, that gets you to an out of 100 score. However, there is something else that leads to score. That something else is the school context scaling based on predicted grade and IA score. The way it works is you take the rubric score for the internal assessment, and remember, IB scored those internal assessments, multiply it by a scaling factor that will lead to an out of 100 score, and then that out of 100 score gets multiplied by a school context scaling factor. That number ranges from 0.5 to about 1.5, few exceptions. If the number is below 1, the student will lose value on the internal assessment. If the number is 1 or above, the student will retain or gain value based on the internal assessment score. That leads to the out of 100 score that is converted to the IB score 1 through 7. Let's look at some examples. Again, my example is history. So we're going to take an internal assessment score of 13. That gets multiplied by the scaling factor, in this case 4. That becomes a 52. Now we take into account the predicted grade. In this case, a predicted grade of 3. All students who earn a 3 and 13 will receive a school scaling factor of 0.82. You take the 52, multiply it by 0.8269, that becomes a 43, and that is an IB score of 4. The combinations will work for predicted grades 4 and 13. That will be a scaling factor of 0.8846. 5 and 13, you notice the scaling factor is going up. Though the internal assessment score is the same, the scaling factor is going up based upon the predicted grade. Remember, all students receiving a combination of the same combination of predicted grade and internal assessment score receive the same scaling factor and therefore receive the same IB score. Okay, now, one of the things that happens is that school scaling factor is different from school to school. Let's take the example from Math SL, and we're going to look at School A. School A, a student received an 11 on the internal assessment. That's multiplied by 5, since the internal assessment is out of 20. That will lead to an internal assessment scaled score of 55. You notice the predicted grade is a 4, the IA score is 11. That school scaling factor is going to be 0.6727. That will lead to a 37 out of 100, and that is a 3. That's at school A. Down the road at school B, student receives the same internal assessment score, again scaled by 5 to get out of 100. Again, that's a 55. That's a combination of 4 and 11, the same at school B as it was at school A. But school B's school scaling factor is going to be 0.9818. That's a 54, and that's a 5. So, you notice that the scaling factors in another combination for both school A and school B are dramatically different. Why? Because school A had a history of over-predicting grades. If you look across the bottom, you will see the predicted grade, and across the left axis, you will see the average variance. We're looking at the cohort who was predicted as 6, and then what was their ultimate outcome. In this case, school A was over-predicting. Kids who were predicted as 6 generally earned a 5. You notice the trend gets worse. Kids who were predicted at 5 got only a 4 or perhaps a 3. And the same continues at the 4, and the same continues at the 3. You notice they are way out of what we would expect an appropriate predicted grade variance to be, plus or minus 0.5. Now let's look over at school B. You notice the axes are the same. 6 through 3 predicted grade, the average variance. First thing you're going to notice is school B is well within that plus or minus 0.5 variance. They are fractionally under predicting and very fractionally over predicting at the bottom. As a result, in IB's statistical model, they gave school B's predicted grades greater value than they gave school A. This explains how scores were achieved. If you'd like more information or help with analyzing how your scores were achieved, or how to use this information to improve student outcomes at your school, please contact us at ibschoolimprovement.com, and we will help you out. Thank you very much. Have a lovely day.